Hello, I'm going to go ahead and get started, 10 o'clock. We're going to be talking about recipes for C2 operations on Kubernetes, a little about who we are.
Yeah, I'm Larry Sudo, and I do a lot of cloud security testing and some Windows pen testing as well. And this talk is kind of about how to take DevOps skills and integrate it with your red team operations.
And I am Jeff Holden. I work at the largest college system in the United States, CISO by day, hacker by night. Currently living in an RV with 3 dogs, 1 wife, and 1 kid. Much fun. So the goals of the project is basically to have the KubeRed working in all 3 of the major container systems or cloud providers: AWS, Google Cloud Engine, and Azure. We're starting with AWS, is what we have experience in, so we have it working at this point in AWS. Want it to be automated. You basically put all your configs into one config file, run a script, push it out, and you'll have your C2 infrastructure up and running within about 20 minutes. Portable, inscriptable, so you can make any changes you want to and do it the same each time on even different cloud providers. So if you've been in a coma for the last 5 years and just woke up, what is this Docker thing? Similar to virtual machines, but now it's sharing the kernel. Much more efficient, less use of memory and disk and I/O and that stuff, so you can fit more stuff on one machine. Here's an old example of, whoops, why is that going there? Okay, example of a Docker file. You pick the Docker image you want. In this case, it updates every time it runs, installs Nginx on this file. All right, so Docker's great and all, but what happens when you have hundreds of Docker images? You need a way to organize it and get everything up and running in a organized fashion, do deploys, all that good stuff. So that's where Kubernetes comes into play. So it's the orchestration engine. You can deploy hundreds of different images at once, do rolling deploys, make changes. All the good stuff that the DevOps people want and need is built into Kubernetes. Here's a little example of a simple Kubernetes file that deploys a team server that we're using, the Cobalt Strike team server service for it, sorry. So you have different files for services, deployment of images, pushing out configs to the different Docker images and that good stuff. So yeah, that's basically what the different kind of files that you'll see as deployments for the Docker images, services. You have to define those, what service, what port you're exposing, all that stuff. Helm charts are optional, which we're making heavy use of, that helps us push out services. All right, so what is the COPS thing? It's basically the heavy lifting on, it works in AWS right now and in Google Container Engine. You run it, it sets up all the EC2 instances for you, it sets up the VPCs, load balancers, creates your access list for you. So otherwise you'd have to go through and set all those up manually. Here's an example of how easy it is to set up a high availability cluster and 2 availability zones in AWS. You basically run one command and then just wait about 15 minutes and you have your cluster up and running all in one shot. So once you have your cluster up and running, you do need a way to access it. We're going to be using external DNS. We don't have this implemented quite yet, but this is what we'll be doing. It's basically just a pod. You send it a YAML config file, and it will automatically update Route 53 to push to your load balancer automatically for you. I should also point out that within AWS, the native commands, you can register domains on the fly and set all the zones and everything up that you need to do. And we'll be supporting that in the future as well. So SSL Cert Manager, we're going to be using the built-in Cert Manager function of Docker. You can use Let's Encrypt, so you basically request a certificate, puts it in etc. d secrets, so then you can just reference that in your Docker files, that your deployment files. Sorry. And there's the link to that. We'll make that available. And so that was the easy part, the overview. Since I'm the CISO, I'm going to hand it over now to the real engineer.
Okay, so yeah, so now we're going to get into the discussion of like, so once you have your infrastructure up, what do you do? And how do I get my C2 up and running? How do I get traffic into it? And the background on that is basically, if you've done C2 infrastructure before, a lot of people use for it's basically a redirector to a back end, and a lot of people use the Apache mod rewrite, and then those with rules in mod rewrite to route stuff and to do filtering and rewriting and stuff like that. But if you look at that was traditionally done with the VPCs, but if you look at it now, there's a lot of advanced web proxy technology available in cloud native environments, and that's kind of what we're focusing on. We've seen a lot of adoption of Docker by red teams for red team infrastructure, but not so much in container management and service mesh technology. And then service mesh technology has a lot of promise for sophisticated C2 operations. It's just the nimbleness of your ability to deploy redirectors, change things on the fly, redeploy stuff is just amazing. And then with Kubernetes in the mix, it's really easy to like literally deploy redirectors like almost at will. So that's the background. And then, so we'll talk a little bit about how to get your C2 containerized. This is kind of the simple part with Docker. What we're supporting initially is Cobalt Strike and Merlin, and then we're gonna do as many as possible in the coming months. So this is just building a Docker image for Cobalt Strike from a Docker file. This is an actual Docker file for Cobalt Strike. So we actually in the GitHub there's going to be a section for Docker files, and for each C2 there's going to be a Docker file so you can build an image for it. For Cobalt Strike you need a license, so it's kind of like some of the images won't be available online because you'll have to build it yourself and stick it in a.
I'll add that to the script where you can compose your own Docker file and upload it to your own private Docker hub.
Right. And then this is a sample Docker file for Merlin. And then, okay, so that's what you got your Docker image. So where do you go next? So you're going to want to have this concept. So you're going to want this concept of a config map, and then also the concept of secrets if you're doing passwords and certificates. A lot of this stuff we're automating in Helm charts, but I just wanted, for completeness, discuss what a config map is. And basically, it's kind of like a set of key value pairs in an object that the container deployment can reference. And then this is actually pulled from the Helm chart we're making available for Cobalt Strike. This is the actual deployment file, deployment template in the Helm chart. What this does is this gives you everything you need to deploy your Cobalt Strike image into a Kubernetes environment. And then this is just the rest of it. So that was the whole entire deployment template. And then what the template does is there's a values file, values.yaml file that you populate with the values that these variables pick up, and then Kubernetes handles all the container creation, deployment, IP address, and everything. One thing that's really cool is if people work with the team server, traditionally you have to, when you start it up, you have to provide the password, IP address, and then if you're using malleable C2 profiles, you have to provide that. With this, that's all automated. You just put that into a file, the values.yaml file, and then with the Helm command, you can just deploy it at will anywhere you want, basically. As many copies as you want. You can actually, if you look in the previous slide, you can actually create replicas. So if you have a lot of implants running, you can actually scale it. So you can have multiple Cobalt Strike servers running simultaneously. And then, yeah. So now this is something that's I'm going to get into ingress controllers. So this is actually a service definition. So when you start up the team server, by default you have port 550 for connecting to it, managing it, creating the beacons and all that stuff. You probably want to make that private. So because for initial ingress control we're going to talk about doesn't support non-HTTP HTTPS ports, you're going to have to basically create an ingress controller, load balancer. Actually not an ingress, which is a load balancer for managing the team server. And this is just a sample of how you would create a service that spins up a AWS load balancer connection, so you can connect to the team server in a private VPC. Yeah, so that's that. And then this is the server's definition for the Cobalt listener. This basically is the port 80 that the beacon checks into. And then if you use certificates for this case, in the case of the Merlin C2 server, you'll need certificates because it's TLS by pretty much by default. So you want to create a certificate for it. The nice thing about Kubernetes is it'll mount this. You just have to create these certificates as objects, and then Kubernetes will mount this stuff into your container. And then, as we discussed earlier, Cert Manager can automate the actual acquisition and updates of these certificates, and you can just create multiple certificate objects, secret certificate objects, and in your Kubernetes cluster, and then all your different C2s as you deploy them can just pick them up. Yeah, and this is how the certificate's mounted into the container. Okay, so now I'm going to get a little bit into ingress controllers. This is basically how you're going to get the traffic into the C2 server or phishing server, whatever C2 or red team infrastructure you have. Ingress controllers basically are the routers. They're like what used to be edge routers, but they're like software. It's all configurable software now. They're basically like reverse proxies. And this is the Nginx one. And this is just the way you install it. And you want to install it as layer 4. So you can use TCP. So the load balancer it creates can be used for layer 4, not just layer 7. Okay, so config maps and Nginx. So Nginx ingress control is very configurable, and if you're going to do rewriting and filtering in your C2 profiles or whatever C2 server you have, and you're gonna want to see if the beacon or the implant checks in, you're going to want to read something in the headers or that's coming in, and you want to, if it's not correct, you want to redirect it or sinkhole it. you're going to want to be able to do that. And then with the Nginx ingress controller, you're going to have to do some annotations. And also, if you're using C2s that are HTTP2 based, you'll have to add that as well. Yeah. And then this is the actual service definition for an ingress. So the ingress is, this is how the ingress controller is actually configured. And this is basically saying that you're going to allow in the traffic through the load balancer and through the Nginx ingress, and then you put in the annotations and anything that's any type of custom logic that you want, that and everything that traditional Nginx server reverse proxy supports, you have access through to these annotations. And this basically what this does is this is saying if something connects to this service that we set up as Cobalt Listener, which is basically the Cobalt Strike team server, just if something hits URL/, this is one without a malleable C2 profile, just route it directly to the Cobalt, the team server. And then now we're going to go into a little bit of the details of redirection. I'll focus on Nginx ingress first because that's really popular in Kubernetes. And then the one we like best is Istio. We've had a lot of success with that, so I'll spend quite a bit of time on that. So this is basically running Nginx as a redirector. So you have your implants, you have your load balancer, you have the Nginx ingress controller, which when you install it, automatically creates the load balancer, and then the ingress resource is where you can figure the routing and the filtering, and whatever redirection you're doing, and then that's your back end stuff, your C2 server, team server, and then if you have like a payload dropper or phishing server, you can actually route to that as needed. Yeah, and these are the annotations for in the ingress object, that in the ingress definition or manifest as you call it. You have to reference this, and then I'm going to show some examples, but just to point out that the annotations to do rewrites and annotations to do what's called configuration snippets, which is actually how you specify stuff, rewrite and very specific Nginx directives. So if you have some experience with mod rewrite, you could actually, and there's a lot of examples on the out there on using mod rewrite to create filtering and redirection. You can actually convert it to Nginx rewrite and then drop that into your ingress manifest, and then you can basically reuse stuff. So then if you want to do sinkholing and stuff, you'll have to create a backend, and that's a backend. So basically that's something outside of the cluster. And so if something doesn't match on the ingress inbound in your filtering rule, then you can send it to what's called an external name, and this would be like something like google.com. Yeah, then this would be the final definition. This is an ingress definition, which does a match on the regular expression on the user agent. So that's like you parse out that what's important to you in the user agent, and then if that doesn't happen, then you basically redirect them to google.com 404. So this is just a very basic rewrite redirection filtering rule that you can customize for your C2 environment. Yeah, and then this is just the rest. This is just the rest of it. Yeah, this is just another example of a rewrite rule. Just check. This is a server snippet as opposed to configuration snippet. This just checks the user agent, and then if that's not in the user agent field, then it just returns it to a different URL. And then if you're using TLS in your C2, you'll want to do SSL pass-through. So basically, if the C2 server is TLS, configured for TLS, you're going to need to let the TLS traffic hit it on the back end. And then this is just the way you set up the ingress controller to do that. And then we'll have this stuff, most of the stuff automated though in the project. This is for the details for completeness. And then once you get it all configured, you have your ingress rule, you have all your rewriting, filtering, redirecting set up, then you can use this Kubernetes command to, and that's actually the pod. So you'll see you'll have your ingress controller running as a pod, and then you basically can check its nginx conf to make sure that all your rules are correct. Okay, so now I'm going to talk about the service mesh. Service mesh is actually under the. It's basically a proxy that sits on each container cluster or pod, as they call it in Kubernetes, and it's fully controllable by YAML policy. So you can actually have it on the edge as an ingress controller, or you can have it on every single pod in your cluster and do very sophisticated traffic management, traffic analysis, redirection, all that stuff. So initially we were working with nginx ingress, but then when we realized that service mesh is probably has a lot more functionality, and it was actually it's a lot easier to set up. Initially, it's conceptually a little different, but once the Istio project's ability to do very sophisticated traffic management, it's very impressive, and it's really useful for C2 infrastructure. And basically the way it works is you've got the Envoy proxy sitting on a node. That is actually an ingress node. It allocates a load balancer, and then you configure that, and you configure the routing, the filtering, the redirection, all that stuff on there, and then you have your C2 services deployed in the back, and then you route to them based on the ingress traffic. And yeah, the Envoy proxy is basically the core of this. I don't know if people are familiar with Envoy. Envoy it comes out of Lyft. It's probably the most advanced edge proxy available, and you can use it by itself. But what the Istio project did is they created a whole sort of a management infrastructure around it. You can now deploy as many of these Envoy proxies as you want, and just control the policy from a central location using the YAML. And it's fully. Another nice thing is the Kubernetes ingress is kind of focused on ingress definitions are kind of focused on HTTP, HTTPS. With Istio and Envoy, you have full TCP, HTTP, layer 7, layer 4. You can actually, if you have a C2 and you want to do DNS, no problem. Yeah, you can actually do DNS. You can actually do HTTPS, 80, whatever you want simultaneously in one configuration. So this is it. This is installing Istio. This is actually we've automated all this, but I just to show you what it involves. And then once you install Istio, this is what the ingress controller looks like. This is the ingress controller. That's the load balancer that's attached to it, and then you can actually specify what ports you want the ingress controller to have available, and these are just some default ports that are there, but it's all configurable. And you could have multiple ingress. So let's say you translate that to your redirectors. So with this, you can just basically script out all your redirectors, how many you want. You can have as many as you want, as long as the cloud provider and you have the resources. You can spin up as many of these redirectors as you want, and if they get blocked, you can just spin up another one, and it's just from a very simple YAML configuration. And then, so when you do configure a redirector, there's a file values.yaml in the Istio distribution, and then you can go in and you can set the name. Then you basically cut and paste this thing in, and just as long as you give it a new, if the ingress gateway a new name. So this is Istio ingress gateway. That's the default ingress gateway. As long as you give it a new name, multiple of these ingress gateways. And you can have them listening on different ports. Each ingress gateway will have its own load balancer, so it will have its own unique IP address. So if you need multiple redirectors and with different IPs, if things get burned, then you can kind of set it up that way. And then you can also deploy your own ingress gateway. That was the values.yaml that drives this configuration from a Helm chart, but you can actually deploy your own as well. But a lot of this stuff is we're handling, we're automating. So you'll be able to just from the kubred command line just deploy an ingress gateway. Just tell it what its properties are, and it'll create a new one for you and deploy it. And then, so now you have your ingress gateway launched, or multiple ingress gateways launched. Now you want to configure it. And this is basically how you configure it. You create what's called a gateway, which actually exposes the ports on the ingress controller load balancer that you're going to bring into the cluster that you're going to attach to your C2 environment. And then you create what's called a virtual service, which actually is the mediator between the gateway and your pod, and the pod, the actual running container. And then with that, you connect the traffic to your C2. And then, so this is a gateway configuration. This actually takes the traffic from the ingress controller load balancer and exposes it to the cluster, and basically exposes it to Istio's management of Envoy. So then and this is basically the entry point to the mesh. And so in this case, this is an example of what the entry point to a mesh that's kind of focused on Cobalt Strike's team server looks like. So we're bringing in port 80, we're bringing in 550 to do the administration, and then we're 443 as pass through. If we're doing SSL on this team server for the beacons, the nice thing about it is it's much easier to configure than Nginx ingress, and so I think it's a better way to go. But we're going to support Nginx ingress and Istio service mesh in this project. And then the virtual service, as I mentioned before, it defines the traffic routing rules. to apply when the implant or beacon comes in, it's gonna hit a host name, and then so the virtual service will get notification of that, and then that specifies the routing rules to access the actual running container. And then in here you can do like what we talked about in Nginx Ingress. Here you set up your matching rules to do rewriting, filtering, etc. And it's another nice thing about Istio is it fully supports HTTP, TCP, HTTP2, UDP. I mean, whatever your C2 is, you can actually specify routing rules for it. And then you can also attach to each ingress controller, you can attach multiple domains. Like you can register a whole bunch of domains on one ingress controller, and depending on which host a beacon or implant's checking into, you can route it to a very specific backend. Yeah, and then this is a virtual service for a team server, which uses a team server gateway, which we saw before, which exposes those 3 ports, and then this matches on port 80. If it matches on port 80, it'll just send it to the team server. Also, if you have a malleable C2 profile enabled, you can. This for example in the what we're releasing, we just have a sample of a very simple malleable C2 profile, and this is just matching on the user agent in that malleable C2 profile. And so basically the way it works is this is an AND rule. So if it matches on the user agent and it matches on a prefix, a URI prefix, if you have worked with malleable C2 profiles, you notice you can set URI prefixes for where the beacon connects to send data. And so if you match on that, then it'll send it to team server. If you don't, it'll send you to google.com. So you can do you can work out all the filtering and redirection with, and there's a whole language. You can go to the Istio site. There's a whole bunch of functionality you can use in these matching rules. So you can get very sophisticated. And it's in its very simple plain English YAML, much easier than messing around with all those annotations in Nginx Ingress. So we found it to be a lot easier. And also TLS. If it's a TLS connection coming in, then you just basically check to see if it's TLS and then send it. If it's TLS and it's hitting that host, then send it to the team server service. If not, then send it to google.com. So you can do all that stuff. Yeah, this is a string matching. So all the matching rules, you can do an exact string match, a prefix-based string match, or you can do ECMA script style regexes. So you can do full regex match on anything in the HTTP request of the beacon. So just some tips on Istio Ingress Gateway. We have a selectors used by Istio to select the Ingress Gateway. So basically, when you create a virtual service to do the routing rules, you'll want to basically select which Ingress Gateway you're going to receive the traffic from, and basically, which is the gateway is really you're like your redirector for that particular virtual service, which is your routing rules for whatever containers that you're using for the C2, and yeah, so that's it. And then there's something with port naming. When you create ports to bring in the gateway config, you have to give it a name, and the name has to be prefixed with the type of protocol that that particular port is running. So these are just, and then you just, the suffix doesn't really matter. So that's just something to think about. And then so when we saw in the previous configs, we were saying that if there's no match to certain prefixes or certain user agent properties or values, then send it outside the mesh. Send it somewhere outside, maybe back to the target, out to some other external site. By default, Istio lets Envoy pass through, so you don't have to really do anything. You can just specify those destinations to wherever you want based on your matching rule. Yeah, it's on by default, but you can test it here with this command get config map istio-n istio system, and if allow any is there, then it's allowed. The interesting thing is, and this is maybe not for red teaming, but the service mesh allows you to control access out of the cluster. So you can actually set this to turn this off, and then no traffic's allowed out of the service mesh unless you specify egress points. And you can have a single egress point. It's called a service entry, and you can specify these places that the services in the mesh are allowed to talk to. Okay, so yeah, some notes on ingress capabilities. A mesh can have any number of gateways, and multiple different implementations of the gateway can coexist. Yeah, so the routing API expresses the routing needs of Istio, and the Kubernetes ingress is kind of focused on HTTP. And then, so that's why Istio service mesh is better, because then you have the full gamut of TCP, and if in your C2 infrastructure, if you're using like phishing servers, you're using DNS and stuff, it's good. Let's see what else here. Okay, all right. Yeah, actually we have a little demo to show. So Jeff's gonna do the demo.
All right, so here we will do a video, because I don't trust the demo gods, and plus it takes too long. So let's get this bigger. All right, so here is the script as it is in its present day. Starting it up, now I'm giving it a name for the cluster, called it legit C2. Now we're just going to deploy the cluster. This is running cops to deploy everything. This in particular is it's not an HA cluster. It's got one master and 2 nodes. And here it's going through all the AWS things that it's setting up. So it's running all this. Let me fast forward through this a little bit here, because no one cares. And then it waits for the NAT gateway coming up is the thing that takes the longest, up to 5 minutes. And then what happens is once it is up, then I pause the video. You have to wait about 10 or 15 minutes. I'm going to have this all scripted where it will automatically check the status of the cluster. And once it's up, then we will go ahead and do the deploy. So here's me checking that the cluster is up. As you can see, it's ready to go. Then the next step we're going to do is actually run and deploy Istio and the Cobalt Strike server, or pod. So it's installing Tiller. The Helm, and right now it's super hacky. This code will be probably released on Monday at the earliest, because I need to go in and actually fix it and make it pretty. And right now I have really bad sleeps in between the commands, so that everything is coming up instead of checking the status and then running the next command. But it works right now. Getting Istio all set up. And go forward here a little bit. There's Istio. If you creates the namespace for Istio. Created the secret for deploying to the from the private Docker image. Now it deployed the team server. And then there's 2 more steps where it creates the routing for the ingress controller. And then I switch over and run a command. Get the pods. Have to grab that team server ID tag right there. This was command history.
Notice that there's actually 2 containers running on this team server pod. So the reason that is because an Envoy proxy is in there as well. And Istio had injected an Envoy proxy into the team server pod. So now you can see you've got a fully deployed team server here with malleable C2 profile. Okay, so got that covered. And then just a few more things to discuss. So as you pursue automation, there's some CI/CD. You might want to put a CI/CD pipeline as you build, your different C2 deployments, images. There's this thing called drone. It's basically lets you build containers and lets you deploy stuff into Kubernetes. You can pretty much automate. You see, if you have certain configurations of C2 you want to just deploy out really quickly, you can use drone. You can put in our kubered script, and then all your containers, all your deployments, and then you can just kick them off as you need them. And it's just very, very popular in DevOps, and could really do a lot of automation. And also you can stick everything in a Git. So you can put all your stuff in Git and then have drone pick it up from Git and then deploy it into the cluster. And then this is kind of a build pipeline in drone. So this actually builds a Docker image, runs a Helm chart, deploys everything. Now, also, just covered this briefly here. You can actually monitor your C2 in Kubernetes with something called Prometheus. Prometheus is basically a time series based system. So it focuses on events, time-based events. We're actually working on a configuration for the team server. So this is so you can see the implants checking in, and so you can do real-time implant monitoring. So if if the implants is not checking anymore, you can. People found your particular redirector, you can quickly just spin up a new one. So we're basically writing a Grok exporter for the team server. Now, if you have your own C2 that you're writing, or there's another C2 author, they can actually instrument their code with Prometheus such that it's automatically supported. So any events they generate inside their C2 server, that Prometheus can just pick it up and put it in a Grafana dashboard or something like that. So you get a very nice telemetry of your environment. And then JMX is for Java. That's something we're trying to see is does Cobalt Strike support JMX? We don't know, but if it does, it makes it a lot easier. Yeah, so there's a couple ways if you like if that particular C2 server doesn't support Prometheus, you can use Google MTail, which is basically a way to extract time series data from a log. And then you can also use Grok Exporter, another way to pull this time series data into Prometheus. And then I said, so we're going to make something available in Grok Exporter so you can monitor your beacon check-ins. And then this is a dashboard from a company called Sysdig, but this is the kind of stuff you can do. You can watch all your beacons and implants and where they're checking in from, how often they checked in, performance and everything. So I think it'll be pretty nice down the road. And then that's pretty much it. These are some references I think are worthwhile taking a look at. And this is basically, this should be up sometime over the weekend or Monday. And this is going to have the basic cube-red script. It's going to have the full Cobalt Strike deployment, the Helm chart for Cobalt Strike, and maybe the Merlin chart as well if I can get it done. But that's coming, it's almost done. And then over the next few weeks, we'll try to do some more C2. And yeah, that's basically it.
Any questions? We got about 5-10 minutes left. I don't know, 5 minutes left, 4 minutes left. Questions? No? Yeah.
So, I saw that you had a delete function in there as well. Does that tear down all of the infrastructure for, say, like AWS, will get rid of your VPCs,
Yep.
EIPs, and whatever else?
It completely tears down. Sorry. Yeah, the question was, does the delete function in the cube-red tear down all the infrastructure? And the answer is yes, it does take down the whole infrastructure in AWS. All right, thanks you. One more question?
Yeah, just a quick question. How long are you keeping your clusters living for, usually?
I mean, right now we've just been testing it. Oh, sorry. The question